Hello everybody, welcome to the video. Today we're going to be going over how to graph the general form of the equation of an ellipse, which looks like this, where x and y are variables, a, b, c, and d are going to be coefficients of x and y, and f is going to be your constant, okay? And in this equation for an ellipse, a does not equal b, because if a was equal to b, then this would be a circle, but this is going to be an ellipse right here, okay? So that's what we're going to be going over today. So just like when we graph the general form of the equation of a circle, what we want to do is this. We want to go from general form to standard form so that we can identify the center and the a and b value so that we can graph our ellipse is what we're going to do. So we're going to do this example right here. We're going to graph ellipses in general form, and you're asked to graph this equation, okay? So first of all, you should recognize that it's in the form of the equation of an ellipse. So let's go over the steps necessary in order to graph this. So the first thing you want to do is you want to move the constant by itself and group the variables together. Okay, so that's going to be subtracting 109 from both sides. And then just like with a circle, you want to get the x's together here in red and the y's together like I did here in blue. Okay, and the constant is right here by itself. Okay. Then step two is actually because the coefficient of x squared is not 1 right here, what we want to do is we want to factor it out, okay? Because in order to complete the square, the coefficient of x squared and y squared needs to be 1. So we're going to go ahead and factor out this coefficient of x squared from these two terms, from the two x terms, so that it looks like this, okay? Now, if the coefficient of y squared was something else besides 1, then you would factor that out too. But because the coefficient of y squared is 1, we're just going to leave it like this and bring down the terms, and then of course bring down the constant as well, okay? But the step here was to just factor out the coefficient of x squared, okay? Now that we've done that, we can complete the square. So the middle term here is going to be 8, okay? We divide it by 2 to get 4 and square it to get 16. So that's the number that's going to complete the square right here. So we're going to put the 16 right in there. Now, if you remember from the circles video, when we added a number to this side, we also have to add it to this side. But actually, you guys, we're not going to add a 16 right here. And the reason for that is because even though I wrote the number 16, that's being multiplied by 9, okay? And 9 times 16 gives you 144. So what we really did is we added 144 to this side of the equation. So that's what we're going to have to do to this side of the equation too. We're going to have to add 144 right there, okay? So that's the way to deal with it when you have a coefficient like that. Then what we're going to do is complete the square for the y's as well, okay? So that's going to be -2, this coefficient, divided by 2 squared is -1 squared, which would be +1. So we're going to add 1 to this side of the equation, and because the 1 is not being multiplied by any coefficient, we're also going to add it to this side of the equation as well, okay? So once we've done that, we're gonna go ahead and factor the red trinomial here. So that's gonna be x plus 4 quantity squared. We're also gonna factor this trinomial right here, okay? So like what multiplies to +1 and adds to -2, it's gonna be -1 right there. And then on the right-hand side here, we're going to add up these numbers. So -109 plus 144 plus 1, that just gives us 36, okay? All right, so if you remember the standard form of the equation of an ellipse, that on the right-hand side was 1. So what we need to do actually for step 3 is we need to divide the equation by the number on the right-hand side of the equation to get the equation in standard form, okay? So in this case, that means we divide everything by 36, divided by 36, divided by 36, divided by 36, okay? And we get this, okay? So we have 9 divided by 36, that's going to reduce to 1/4, okay? So we can put we don't need to write the 1 right there, we can just leave it like that. But the 4 goes in the bottom right here. Another way to get this 4 is just to divide these two numbers by 9. Then we have 1/36 right here, right here, that can't be reduced, excuse me. And then on the right-hand side, we have 36 divided by 36, which gives you 1, okay? So that's going to be your equation in standard form. Okay, so I'm going to move the equation at the top here and then move on to the last step, which is just to graph the ellipse. Okay, so in this case, we know the center is at the opposite of 4 and the opposite of -1, which is -4, 1. So we can graph the point right there. That's the center of the ellipse at -4 and 1. We know that since the denominator of the x values is 4, that a squared is going to be equal to 4, which means that the a value is 2. So from the center, we go 2 to the right and 2 to the left to get these 2 points. Let's go ahead and plot. I can get those coordinate points as well. And then finally, we have the denominator of the y's is going to be 36. So that means that b squared is equal to 36, which means that b is equal to 6. So from the center, we go up 6, down 6. We can put the coordinate points of those vertices right here. Remember, the ones in blue are the vertices, and the ones in red are the co-vertices, because this one is longer right here, the ones in blue, a further distance from the center. And then once we have the vertices and co-vertices, then we can just graph our ellipse, and then we have our graph, okay? So what we've done is we went from general form right here to standard form using algebra, and then using what we know about graphing ellipses in standard form to just graph the ellipse, and that's how you graph ellipses in general form.